Hello. In this video, we're going to take a look at the Oracle Dynamic Scaling Engine and the Oracle Dynamic Scaling Engine plugin and how it can control the enabled OCPUs in the Exadata database dedicated cloud systems and Exadata Cloud at Customer. My name is Rob Watson. I work for the Mission Critical Database Specialist team, as does my colleague Sneha. And together we're going to show you how to install, configure, and then use the Oracle Dynamic Scaling Engine. Let's take a look at our demo architecture. In our demo, we have two OCI tenancies. In tenancy 1, we have an Exadata dedicated system, and we also have a swing bench load generator VM. This VM is going to generate the database traffic on the Exadata. In tenancy 2, we have another VM, and this is going to run the dynamic scaling engine. The dynamic scaling engine needs to be able to connect to the Exadata compute nodes via SSH. The dynamic scaling engine could be run directly on the Exadata compute nodes. It can be run on a VM in the same tenancy as the Exadata, but in this example, we're running it in a completely separate tenancy. The dynamic scaling engine also needs to be able to connect to the internet so that it can connect to the OCI API gateways, and it's going to use HTTPS for this connection. If we take a look at the high-level installation of our demo, as we mentioned, the dynamic scaling engine can be configured directly on the Exadata compute nodes, but we're not doing this. So no configuration on the Exadata cluster nodes is required. We will use my Oracle support node, doc ID 2719916.1, to download the dynamic scaling engine RPM. And we'll also use my Oracle support node doc ID 2770544.1 to download the dynamic scaling plugin RPM. Our VM that we're going to use to run the dynamic scaling is going to be running Linux, and we need to ensure that Oracle Linux Developer Release is present and that also the Python 3.6 OCI CLI is in place. It's possible to run the dynamic scaling engine using the OCI CLI command line for authentication. This is optional, so I've marked it as an optional step. If you are going to do this, obviously you would need to install the underlying OCI CLI tool. We need to ensure connectivity between the dynamic scaling VM and the Exadata via SSH, and then we can configure the dynamic scaling software and configure the dynamic scaling plugin. The links at the bottom of the slide are for the OCI CLI and the main My Oracle support node for the dynamic scaling suite. After installation, the dynamic scaling plugin will be installed by default under /opt/dynamic scaling-plugin. And this directory contains the plugin binary and the wrapper script the dynamic scaling software will use. There is a dynamic scaling plugin config file that needs to be edited. There are optional parameters within here, but the two mandatory variables that need to be changed is the path of the key that is going to be used by the VM to connect to the Exadata, so the SSH private key path, and also the cluster ID of the cluster that is being scaled and monitored. If we're going to use an Exadata Cloud at Customer, the variable will be VM cluster _OCID. If we're using an Exadata dedicated system, then this variable will be Cloud VM cluster _OCID. Once the plugin has been configured, it's possible to test the wrapper script to ensure that the connection to the Exadata VM cluster is successful. If we run the dynamic-plugin_wrapper.sh script, it should be able to connect to the VM cluster and provide us some information. And the information it provides is the OCPU load of the cluster nodes, so how busy the Exadata is, and the second value will be the number of unreachable nodes in the cluster, so these are nodes it couldn't connect to. We would want this value to be 0, as we want the plugin wrapper to be able to connect to each of the nodes within the cluster. You can see at the bottom of the slide the highlighted numbers in blue show that when running this wrapper script, we see that the OCPU load on the Exadata is 68, and that there were no nodes that could not be connected to as the value is 0. For the demo, we've written a simple shell script that calls the dynamic scaling engine that's going to be used to control the Exadata. In reality, this will be created as a server on the Linux VM, so that when the VM booted, the script would automatically run, and it would run in a background daemon capacity. If we look at some of the variables on this slide, we can see that the top one, the Cloud VM Cluster ID, is providing the OCI ID of the VM cluster we are interested in monitoring and scaling. We then have to provide the tenancy ID, the user ID, the key fingerprint, the location of the private key that the engine will use to connect to the Exadata. As mentioned in the high-level installation instructions, it's possible, if you already have OCI CLI configured, to pass in an OCI CLI profile, and this will be used for authentication to the OCI gateway in terms of the user ID and tenancy and so forth. If we look at the bottom half of the script, this is where we start to provide information to the dynamic scaling engine on what to do. So interval tells the dynamic scaling software to check the Exadata every 60 seconds. So every 60 seconds, it will reach out and get values from the Exadata. The max threshold value is set to 60. So this means if the OCPU load on the Exadata is greater than 60%, then the dynamic scaling engine should look at increasing or scaling up the OCPUs. The min threshold value is set to 10. So if the OCPU load value on the Exadata is less than 10%, then the scaling script should look at removing OCPUs or reducing the OCPUs. The max OCPU count is a hard level limit of how many OCPUs can be scaled. We've set this to 20, so when the OCPU level reaches 20, even if we are over our max threshold, we're over 60% in this example, and we should consider scaling additional OCPUs, it will not do so because it is being throttled by how many the maximum OCPU count at 20. And this is true for the min OCPU count as well. On this example, we've had it set to 4 OCPUs. So even if the system is idle and the min threshold is below 10%, we're not going to get the dynamic scaling software to continue to reduce OCPUs below 4. It will just stay at 4 OCPUs. So these two controls allow us to control what the maximum number of OCPUs on the system can be enabled, and what's the minimum number of OCPUs to be enabled. The OCPU parameter, which we've set to 4, is the number of OCPUs that we want to increase during any scaling operation. So if the dynamic scaling software decides it needs to increase OCPUs or decrease OCPUs on the cluster, it's going to do that in chunks of 4 OCPUs. We then provide the OCI region that the VM cluster is in, and we provide the plugin. So the plugin is the dynamic plugin wrapper script that is going to reach out to the Exadata and return with the load values. The last parameter we've used is no daemon. So for this demo, we're going to run it in the foreground so you can see all of the log messages in real time. Again, in a real world environment, you wouldn't be running it in no daemon mode. You'd want this to run as a service. There are many other options to the dynamic scaling software, and it's worth checking the MyOracle support master note for the software to get all of the different options available. Now I'm going to pass over to my colleague Sneha, who's going to show you how to create an OCI VM, install the dynamic scaling engine and plugin, and configure it.
Thank you, Rob. We will now create a compute VM to avoid doing any configuration on the Exadata cluster nodes. So go to Compute, click on Instances, Create Instance, provide the name and all the required options. provide your VCN and subnet details. Load your SSH key and then click on create. So the VM is now available. So once the VM is available, we can now install the dynamic scaling plugin RPM on this compute VM. Unzip the downloaded dynamic scaling plugin zip file and then install the RPM. As seen here, it's completed successfully and this shows the plugin file. Now let's install the dynamic scaling engine RPM on this compute VM. So unzip the downloaded dynamic scaling engine zip file and then install the RPM. As seen here, it's completed successfully and this shows the executable file. So dynamic scaling will call the plugin and will perform the job. Now the Oracle Linux team packages the OCI CLI and SDK in RPM form and publishes them in the developer repository on Oracle Linux YUM server. However, this section just depicts how you can install the developer repository. You also need to install Python 36 OCI CLI in case we are going to configure dynamic scaling using the OCI CLI. Now I hand over to Rob, who will take you to the further steps in the demo.
We can verify the current OCPU count of the ExaData VM cluster we're going to run the demo on using the Cloud Console. We can see from the summary that 4 OCPUs are enabled, and if we click on the cluster detail page also shows us the information. The dynamic scaling script will also provide us the OCPU current setting. For our demo, we're going to use 3 VMs. The top left VM is going to run the dynamic scaling script. The top right VM is going to run the load generator swing bench, and the bottom VM is a connection to one of the ExaData compute nodes. Running a VM stat on the ExaData compute node, we can see on the third column from the right the amount of idle the system has as a percentage, and we can see on the first column on the left, the R, the run queue, how many items are on the run queue. If we run our scaling script that was shown earlier in the presentation, we're going to run this in the foreground. Obviously in production you would run this as a service, you'd run it as a daemon running in the background. But when you run this script, one of the first things it will do is connect to the plugin, and then it will provide the current OCPU count. The dynamic scaling scripts also provide calls for get OCPU and set OCPU that can be run independently of the actual dynamic scaling script. You can see by running it in the foreground what it's doing. We can see it's checking the plugin and it will return with the current OCPU for the VM cluster. It provides us with the details that have been passed to the script, and at the bottom we can see the OCPU count has been returned as 4. Now let's demonstrate the dynamic scaling functionality. We will start our scaling script again. You can see it firstly returns the current OCPU count 4, and above that we have the parameters that were passed to the script. So things like the maximum OCPUs it can scale to, the minimum OCPUs it can scale down to, and measure intervals, so every 60 seconds in our case. we can see that it's telling us that it has a value from the plugin of 37% of CPU utilization. This is between the minimum 10% and the maximum 60%, so the script will take no action and it will then measure again in 60 seconds time, and it will continue to do this. If we now start our load generator, this is going to apply a load to the database running on the VM cluster. We can immediately see that the run queue has been increased and the amount of idle, which is the third column from the right, has dropped to 0. So the system is now very busy. And the plugin has come back with a value of 99% utilized. So we can see that the system is very busy. The plugin has reported that back to the dynamic scaling script, which has said that CPU usage is over the max threshold of 60%. So before a scaling action takes place, the scaling engine needs to have 2 readings that are above the threshold or below the threshold before it will take an action. So in our case, in our demo, it will need to wait another 60 seconds for another reading to ensure that it wasn't just a spike. So it has another reading, the load value is at 100%. That's 2 readings that are over the threshold of 60%, so it has now issued a scaling command. And we can see at the bottom of the VM window, success, scaling. And we can see if we go to our cloud console, the cluster is now updating. So the scaling engine has requested additional OCPUs to be online. We can see the scale cloud VM cluster CPU work request. During a scaling operation, the plugin will wait for 3 minutes before continuing to try to take readings. And here we can see that the scaling request has been successful and the current OCPU count has been increased to 8. The scaling engine will continue to monitor, and if the CPUs are still over the maximum threshold and it still has room to increase additional OCPUs without hitting its hard limit, then it will indeed continue to increase the OCPUs. The work request has been successful. The cluster is green and we can see the number of OCPUs has been enabled at 8. This concludes the video and the demo. Thank you for watching.